Alrighty, everyone. I'm going to go down the rabbit hole on an article from thehackernews.com. This is from March 2nd, 2024. And the topic of the article is the U.S. court orders NSO group to hand over Pegasus spyware code to WhatsApp. And so what I like to do is when I see an interesting article, I like to kind of scan it, read it a little bit, and then I try to find things that I want to learn a little bit more about. And as you can see up here at the top of this page, you can see where I have clicked on quite a few links as I progress through this rabbit hole. This is actually a pretty good article, and it's a good rabbit hole to go down. And so essentially what it's saying is that the court ordered the NSO group to hand over its source code for spyware called Pegasus and some of its other products to Meta, which most people know as Instagram, WhatsApp, or Facebook. Now, the things that I've already learned from doing a little digging is I know then that the NSO group is an Israeli enterprise that creates spyware for governments to help prevent terrorism and other unlawful acts. And so as I progress through this, I'll read it. I'll keep a keep card on some of the things that I think I want to look at. After I finish reading the article, usually this list gets pretty long, but this is just a demonstration of some of the things I'll look at. I'll look at some very general things, like just try to make sure I know what NSO is, this particular exploit that the software targets is may be referenced as a buffer overflow for some people, the CVE, and then there were some acronyms that I didn't know, and then once again the Pegasus spyware name. And so what I did was I did read this, and as I hover over some of these articles, I'll click on the links and get to other pages. And so the first link that I clicked on actually brought me to another article from the Hacker News, which by the way is a really good site, and it talks about the Pegasus spyware targeting iPhones of the journalists and activists in Jordan. And I think it's actually it can target Androids too, but I guess this particular project, as you might want to call it, was mostly iPhones. Okay, so it says that the iPhones belonging to about 36 journalists, activists, human rights lawyers, and civil society members in Jordan were targeted by this spyware. And then about 9 of them had been confirmed publicly. And so this is kind of a general one. It tells you a little bit more about it. And it also says the NSO group in its 2023 Transparency and Responsibility Report touted a significant decrease in reports of product misuse during the 22 and 23 years. So basically, NSO is claiming to only allow governments to use the software that they sell for, I guess, legitimate governmental reasons, not for malicious purposes. And so their Transparency and Responsibility Report should reflect that. And so that's one of the links that I actually went to. So as I progressed, what I decided to do was, well, let me look up NSO, and I went to their webpage. And so I went to their About Us page, and it says the NSO group develops best-in-class technology to help government agencies detect and prevent terrorism and crime. So that's the good thing that they try to do, and they help licensed government intelligence and law enforcement agencies lawfully address the most dangerous issues in today's world. And that's a hard thing to do, and you never know, even licensed organizations may not always be the most ethical. And if you scroll down here a little bit, and as I move my keep card, you'll see right here that you can click on the actual report and access it. And then again, so this tells me a little bit that the good side of the NSO is to try to help governments protect their countries and fight against terrorism and crime. All right, so then the next tab that I ended up going on again was the same thing, and this is the report right here. And I actually clicked on it, which I will read later because it actually is a pretty long report. And I think I actually have 2 of the same, so I'll click that out. And then also I went to Wikipedia. I really like Wikipedia. It gives you a good history of things. I won't say that I believe that everything is accurate, but it does give you a general idea of companies and organizations and even terms and stuff. So it does tell you right here how the name of the group, what does it stand for? NSO stands for, and I'm not going to say it in case I mispronounce people's names. And it tells you about the spyware, and it also mentions that that particular spyware is capable of remote zero-click surveillance on smartphones. So that's quite a vulnerability. And then I went to exploit, and this was just a general comment. I was trying to look up zero-click, and it just talked about the exploit and what an exploit is. And so if we read this complete thing, it just basically refers to being able to take advantage of something, and it's usually some kind of technology or electronic access kind of thing. And then in lay terms, it says that it's also known as a hack. And then as you progress, I think this is the report. So you can see it's a nice transparency report. It's about 27 pages. And so I'll read that after we finish this. This is just a quick recap on this particular topic. And then I'll also go to a couple other sites and just refresh myself on a couple terms. And when I look up terms, I will try to find sites that have some kind of a good reputation in the field, because usually their descriptions, their definitions are usually spot on. And so this particular site was Fortinet, and I just looked up buffer overflow. And again, just trying to refresh my memory on things and keep current. And it basically says buffer overflow is a software coding error or a vulnerability that can be exploited by hackers to gain unauthorized access to corporate systems. And it may not just be corporate systems, it could be any system. It is one of the best known software security vulnerabilities, yet remains fairly common. So if you go to NVD or you look up CVEs, you'll notice that a lot of them are related to overflows. And so as you progress, so I decided to look this up, and this is where some of the more technical information might fall. And so what I did was I looked up the common weakness enumeration. I clicked on it, and this is what I got. CWE 119 is improper restriction of operations within the bounds of a memory buffer. And then so if you actually read this, it actually gives you quite a bit. And notice you can go up here and you can click on some links that give you different views. So the description of this particular CWE is the product performs operations on a memory buffer, but it can read from or write to a memory location that is outside of the intended boundary of the buffer. And then the extended description. Certain languages allow direct addressing of memory locations and do not automatically ensure that these locations are valid. So that's a key point for programmers, and then for the memory buffer that is being referenced. This can cause read or write operations to be performed on memory locations that may be associated with other variables, data structures, or internal program data. As a result, an attacker may be able to execute arbitrary code, alter the intended control flow, read sensitive information, or cause the system to crash. So basically a bad guy can take advantage of this vulnerability and cause you a little bit of heartache. And it has some alternate terms. If you really like to read the alternate terms, sometimes they get a little interesting, and this one in particular has different meanings for different audiences. It references this term should be avoided where possible. I guess it's too generic for them. Some researchers, developers, and tools intend for it to mean right past the end of a buffer, whereas others use the same term to mean any read or write outside of the boundaries of a buffer, whether before the beginning of the buffer or after the end of the buffer. And so it sounds like basically saying people are using the term differently. And so if you want to be a purist, you might want to try to come up with a focus on another term. A buffer overrun, some prominent vendors and researchers use the term buffer overrun, but most people use buffer overflow. See the alternate term for buffer overflow for context. And then memory safety, generally used for techniques that avoid weaknesses related to memory access, such as those identified by this particular weakness in enumeration and its descendants. However, the term is not formal, and there is likely disagreement between practitioners as to which weaknesses are implicitly covered by the memory safety term. So it's just kind of giving you a heads up that some general terms might be discussed as not being appropriate, or there might be a better term. And so this actually shows you relationships, and so you can actually scroll down this stuff. It gets pretty interesting, but it does take a long time to read. And I actually like some of the common consequences, and then likelihood of exploit, which is high. But here's something that I think a lot of people who are technical will like. It gives you demonstrative examples. And then example 1, this example takes an IP address from a user, verifies that it is well formed, and then looks up the host name and copies it to a buffer. So this basically tells you that someone's programming and that they are using this, and they're taking the IP address and they're trying to verify that it's well formed, and it looks up the host and it copies it to the buffer. Okay, so this function allocates a buffer of 64 bytes to store the host name, goes into a little bit more detail. And then here's another example, example 2. This example applies an encoding procedure to an input string and stores it into the buffer. And so again, it kind of shows you how this stuff works, and it explains it. And I think that there, let's see, I thought I saw one that told you where the mistake was, but you can see where there's quite a few. Example 5. So these are quite a few examples. And so this actually is very interesting, especially if you're getting into the programming, or if you're in computer science, or on the computer science engineering side. So check it out. Might give you some insight. Here's some examples of some of the vulnerabilities. And then here's some potential mitigations, which is, again, good for people who like to program or need developers. Strategy language selection: use a language that does not allow this weakness to occur, or provide constructs that make this weakness easier to avoid. For example, many languages that perform their own memory management, such as Java and Perl, are not subject to buffer overflows. Okay, architecture and design phase: use a vetted library or framework that does not allow this weakness to occur, or provides constructs that make this weakness easier to avoid. And then it gives you a couple examples. And then in the operation, build, and compilation phase, it gives you some hardening opportunities to help prevent. And then implementation: consider adhering to the following rules when allocating and managing an application's memory. And then so you can double check that the buffer is large enough. When using functions that accept a number of bytes to copy, such as string copy, be aware that if the destination buffer size is equal to the source buffer size, it may not null terminate. Check buffer boundaries, and then if necessary, truncate input strings. And so, and then you have some more phases as you go down. And so it's really kind of very detail-oriented. It's very structured, and it's very informative. So if you are working on this, or you're taking classes on this, don't forget that the MITRE site for for common weakness enumeration is very good. And now the next site that I will go to the MITRE attack site. And so this is, let me zoom out just a little bit. And so what I did was I looked up Pegasus, and then I chose Pegasus for iOS. And again, this is just me trying to learn a little bit more. I'm not going to be an expert or anything, but this site is very good. And if you really want to get into computer science and cybersecurity, this is definitely a site you should know about. And so it really kind of gives you some basic information. It says Pegasus for iOS is the iOS version of the malware that has reportedly been linked to the NSO group, has been advertised and sold to target high-value victims. Android version is also available. And then it tells you the ID, it tells you what it is, which is malware, it tells you what operating system that it affects, and when it was created, and when it was last modified. And then if you scroll down, it'll tell you about some of the techniques you used. And you can see quite a bit down here. It says it has the ability to record audio. Just going to skip. Update and sends location of the phone, out-of-band data, uses SMS for command and control, captures logs. And so if you scroll down, it looks quite interesting. And then down here are some references. And so if you click on the references, you can even get more information. And so you can see where this can actually get like pretty, turn you into a long read, get you down quite a rabbit hole. But if you like technical information, it's really cool. If you just like to learn a little bit more about what's out there, like me, you can scan everything and learn quite a bit. And then when you're reading things, make a short list of some of the general terms or things you want to look up. And then if you, as you progress, you can click on more and more links, and you can spend the whole day focused on one particular article. Well, that's how I do it. Hope it helps.